Hello everyone, welcome to Analog IAS. In this video, we'll be discussing about the launch vehicles of ISRO, that is PSLV and GSLV. Before moving to the launch vehicles, let us understand what are the satellite orbits. There are two types of satellite orbits. One is the sun-synchronous orbit and the geostationary transfer orbit. The sun-synchronous orbit falls in the range of low Earth orbit, that is up to 2000 kilometers from the distance of the Earth. That is, this sun-synchronous orbit, the satellite moves from pole to pole, and the position of the satellite in the sun-synchronous orbit when viewed from a particular position on the Earth and the particular time has the same solar time. While there are two variants of the geostationary transfer orbits, they are geosynchronous and the geostationary. Here geosynchronous means it is synchronous with the rotation of the Earth. That is, the satellite completes one rotation of the Earth in 24 hours in the same way as the Earth completes 24 hours in one rotation around itself. And the geostationary orbit is a particular case of a geosynchronous orbit where the orbit is particularly above the equator. These two satellite orbits are at a height of 36,000 kilometers from the Earth. Let us understand the difference between geosynchronous and geostationary orbit with an example. Suppose I am looking at a satellite which is in the geosynchronous orbit, and if I can see that satellite today at 1 am, I can see the satellite again tomorrow 1 am and not in between. This is called the geosynchronous orbit. While in case of geostationary orbit, if I see the satellite at 1 am today, even if I look at 1 am or 2 am on the same day, the satellite remains the same. That is, the satellite position gets fixed to a particular point on the Earth. The thumb rule to be noted here is, if a satellite has to be transported to larger distance, that is 36,000 kilometers, the fuel required is in the launch vehicle is more. And in case of low Earth orbit, that is up to 2000 kilometers, the fuel required will be less. Now let us look into the PSLV. This is called the Polar Satellite Launch Vehicle, as the satellite in this system moves from pole to pole. The PSLV can carry a satellite of weight up to 1750 kg up in the low Earth orbit and up to 1425 kg in the geostationary transfer orbit. It consists of 4 stages, that is solid, liquid, solid, liquid. And in the liquid, the propulsion is carried out by the KAS engine, which is developed indigenously by the ISRO. This is one of the successful launch vehicle ISRO has it has only 2 failures in the 50 launches. There are 3 variants, that is PSLV, base, core alone and the XL. The difference is because of the weights of the satellites that these launch vehicles carry. Now let us look into GSLV. This is the geosynchronous satellite launch vehicle which was developed by the ISRO. This satellite launch vehicle has a capacity to transfer 5000 kg satellite in the low Earth orbit and a 2500 kg satellite in the geostationary transfer orbit. It has 3 stages. The first stage is the solid, and the second is the liquid, which is propelled by the KAS engine, and the third stage is the cryogenic. Here the fuel are maintained at the negative temperatures, and it also helps in boosting the thrust of the launch vehicle, and this is propelled by the CE 2.5 engine, which is developed indigenously by the ISRO. It has 3 variants, that is Mark 1, Mark 2 and Mark 3. Mark 3 has been recently used in the Chandrayaan-2 mission and will also be used in the human spaceflight mission, as this has the capability to launch 10,000 kg in the low Earth orbit and 4,000 kg of satellite in the geostationary transfer orbit. Please pause the video and solve for this question. With reference to India's satellite launch vehicle system, consider the following. We can see that the third statement is wrong because GSLV is a 3-stage satellite vehicle launch system and not a 4-stage. Therefore, 3 is wrong. Now let us look into the second stage. Satellites launched by PSLV appear to remain permanently fixed in the same position in the sky as viewed from a particular location. This is not the case with the launch vehicle. This is the case with the satellite system. Therefore, this is also wrong. Therefore, the correct option is A. Thank you.